sit down and look back thoroughly. Look at all the evidence. There is nothing wrong in asking a colleague. And that is why in the process industry, we are always preaching teamwork, because no one knows it all. What you see today may not be seen again until maybe after 5, 6, sometimes even 10 years. So experience is good. Yeah, it's good because something will happen that someone, oh, I have seen it. When we're doing this, this happened. So that is why in the process industry, it's not good for one to be an island. Teamwork is always preached. And when you have that mind, then the impact of poor communication, information handling is eroded. And in that case, it will improve process safety. So this is what I can say about the safety moment today, except if there are 1 or 2 contributions. Okay, in the absence of any contribution, we will go into the presentation for today. And today we are happy to have Engineer Raheem Alabi to talk to us. And Engineer Raheem Alabi is an experienced engineer. Engineer Raheem Alabi is the Deputy Manager, Process Safety, West Africa Gas Company Limited, and serves on its Operations Leadership and Technical Committee, overseeing operational risk management process, process safety engineering, and management system implementation across West African gas process facilities in the sub-region. Engineer Raheem Alabi has facilitated various key risk assessment workshops and play a key role in facility change management process, pre-start set of safety review, incident root cause analysis, control of major accident hazards, key project risk assessment and hazard workshop facilitation. He is also involved in development of strategies that has to do with HSE objectives for corporate planning of the company. Prior to joining WAPCO, he was with Pan Ocean Oil Corporation Limited as an HSE process safety engineer, as well as Kakasa Nigeria Limited Engineering, Technical and Services Division, and NETCO NNPC as a process engineer. He was part of USAN FPSO engineering design team in IESA Lagos Engineering Office on secondment from Kakasa. He has a Bachelor of Engineering in Chemical Engineering from FUTMINA and Master of Process Engineering from University of Lagos. He also earned certificate in risk-based process safety management, ILM Level 3 certificate in leadership and management, as well as diploma in strategic management. He is married with children and member of NSChE, AIchemE. He likes music and picnic. So this is the profile of Engineer Raheem Alabi, and without much ado, I would like to welcome Engineer Raheem Alabi to take us through his presentation.
Good afternoon, everyone. Many thanks to the coordinator and the entire HES senatorial group for this wonderful opportunity to present this paper today. I don't know whether you are hearing me.
Yes, we can hear you loud and clear.
Okay, thank you. I'm Raheem Alabi, and I'm going to speak to you about quantitative risk assessment as a process safety tool. And the outline is going to be as follows. We are going to introduce the course. We are going to look at the objective of the quantitative risk assessment. We are going to look at benefit of quantitative risk assessment, then a simplified QRA process. Then we are going to also discuss application of QRA, and a case study will be presented. I will start by saying that everybody knows that every business has its unique inherent risk. Therefore, business owner need to adopt risk tolerability criteria based on his or her risk appetite. Risk is about the combination, the product of probability and consequences, as we are all aware. The combination of the chance that a specified undesirable event will occur, and the severity of that consequence will also manifest. And tolerability criteria is just a screening criteria which express the level of health, safety, and environment, as well as assets, which has to do with loss of facility or loss of production, then deemed tolerable for a given period of phase of activities. As you are aware, probability is just the likelihood of an incident or accident occurring, or loss of control or hazard being released. While consequence is talking about the impact that release of energy or hazard can cause and how bad it can be. That is why one of the key characteristics of a good safety company is you maintain a sense of vulnerability. What that does for you is it helps you to look at your risk and say, okay, what can go wrong? Now, if you are able to identify what can go wrong, you will ask yourself, who can be harmed? If you identify that, then how bad can it be? That's evaluation. Then that will help you to say, okay, what are the preventive measures, safeguard I have in place? If you go after that, you look at mitigative measures. If you're able to answer all this, then you determine that, oh, my risk is this. Then you compare your risk with risk tolerability criteria. If it is lower than risk tolerability criteria, you can say your risk is as low as reasonably practicable. But if it is above, you are required to do more by providing more mitigative measures so that you can bring the risk to low. Now, I would like to also look at qualitative and quantitative. There is a link between them, and there is also some similarity. Both are risk assessment tools used to identify and analyze risk. As we all are aware, the last session we had with engineer Adetono, we talked about ASOP. ASOP is a typical qualitative risk assessment whereby you gather multidisciplinary team, and the result of that ASOP is dependent on the experience, exposure, and understanding of the process of the team. Based on that, it's very, very subjective. If you give the same process to a set of team in Nigeria and you give it to another team in London, they might come up with a different result in terms of safeguard and mitigation, depending on the understanding of the process. But as regards quantitative, it's very objective. It has a methodological process. It's a quantitative in nature. It's a calculation process. Whereby, calculation 2 plus 2 in base 10 is 4. If you take it to London, UK, Europe, unless you change one of the parameters, that is why quantitative is more objective than qualitative. Now, the link between the two is actually because when you carry out ASOP as a qualitative risk assessment, you summarize the scenario into a major accident hazard. Now, when you summarize the scenario into different hazard, now from there you consider those that are considered major accident hazard. Then you subject it to structured approach for detailed and objective analysis. For instance, if you look at the risk metric I presented in my slide here, it's just
and that's for me to talk.
Hello? Can I go ahead?
Yes, go ahead, please.
Go ahead, Alabi, go ahead.
Okay, sorry. Now, if you look at that risk matrix, basically the zone red, any hazard or any scenario identified to be in zone red are considered major accident hazard, and they are meant to be subjected to further analysis using QRA. Basically, that's the link between the qualitative and quantitative. And objective of QRA basically is it provides valuable insight into the features of the industrial plant, highlighting those aspects where failure may arise and cause injury to operator, public and environment and asset itself. And it also provides basis for decision making in design and operation of the plant, and also require legally to show fitness to operate to regulatory agencies. For instance, in UK, HSESG is part of what they requested for as part of package for you to get approval to construct or to modify facility the same thing OSHA in US. And I believe DPR in Nigeria does the same thing, because in the requirement, there is a session I saw, safety review. This part of the review that they are going to carry out to determine if the facility is safe to operate. Now, benefit of QRA. QRA provide input on safety issues, including the design, operation, and regulation of facility activities, both onshore and offshore. It also provides a rational basis for monitoring risk and providing specific decision-making guidance. Now, in that regard, it helps in decision-making and target for risk reduction. For instance, if you calculate your risk and you realize that your risk is within the medium range, then by the time you provide mitigative measures like passive and active safeguards, for instance, you can recommend that they need to build a blast wall. Blast wall has a safety factor. That safety factor, by the time you put that in your calculation, it's going to bring the risk down. Then you can now fall within the range of low risk. Now, the same thing for design basis for fire and blast protection. Like I said earlier, if you look at the situation that I described earlier, you may need to provide blast study. The output of the QRA will serve as input to the design of fire and blast wall protection, so that you can determine the amount of radiation and the blast impact that wall will be able to withstand. Then design concept selection and cost benefit analysis. It also helps when you have various design to choose from. QRA can be used to determine which one is safest. For instance, if one has a more number of potential leak points compared to the other option, it may be better for you and safer to choose the option which has a lesser potential leak point, and you can operate it at a lower pressure, because those are the major contributions to blast and fire. Now, you can also use QRA to demonstrate a lab in case you have a situation where you need to demonstrate to the regulator that this situation has been brought to a safe level. Then it also helps you to identify safety critical procedure and equipment, because all those safeguards you put in your QRA that provided the risk to become a lab, you are going to identify them as safety critical equipment or procedure, whereby those procedures, we are going to now program them a computerized maintenance management system for thorough tracking of their preventive maintenance, so that at every point in time you call them to call, they will be able to act as intended. Then it also helps you to determine a safe distance or buffer zone between two facilities to prevent domino effect, and also between a residential and industrial area. For instance, what happened in Abule Ado in Festac is a typical QRA failure, because a LPG plant is at 100 bar and there's no blast wall, there's no safe distance. Now, assuming that they are unable to provide a safe distance around there, and they should be able to build a blast wall tall enough to withstand that explosion of a pressure, to the point that you can see the kind of property damage we have in that area. Now, yes, this is a simplified QRA process. If you look at this process, I put a reference there. If you click that reference, it's going to take you to a whole QRA report. Typically, I was not involved in that QRA. The one I involved in it is not in public domain. But this particular one is in public domain. That's why I put it there, so that people can have further information from it. But basically, it's just for you to look at your scenario. For this particular one, they look at storage of explosive facility. Transport is for an explosive facility producing facility company. Then they look at vulnerability receptor, preliminary hazard identification. That is where I talk about ASOP. Then data collection. Then you look at your population data around the facility. Then historical review. Basically, then you go to frequency examination, frequency estimation, consequence analysis. Then you evaluate your risk, compare it with risk criteria. Then if it meets risk criteria, your QRA is complete. If it does not, you need to provide mitigations. Then you need to do cost benefit analysis. Then you go back to reevaluate your risk again. That's just a basic QRA process. Now, QRA result is usually displayed in two ways. For individual risk, which is more like a personnel of the facility, the risk around them, there is a local specific individual risk. This indicates the risk at a particular location, and it is the risk for hypothetical individual who is positioned in that area for 24 hours per day and 365 days per year. These are the calculation you are going to get. That is how it's going to be quantified by the QRA software. Then there is also IRPA, that's individual risk per annum. This also going to translate the result of local specific individual risk to annum basis criteria, and is the risk of fatality per annum for a named type of worker. That's a kind of group of worker. It takes account of the named type of worker being considered at different locations for different length of time, and it is usually used in the offshore facility. And what you normally use as a basis is 20 weeks per year. That's the basis for calculation, because there is a simple calculation that you can transpose the result of local specific individual risk to individual risk per annum. Now, the one that has to do with public is usually in form of fatality versus number of population curve. The sole plot of cumulative frequency versus population, which is n, and sustain a given level of harm from a defined source of hazard. This method incorporates detailed description of the population around the facility and each individual incident outcome, which has its own frequencies, mapped with the population information to determine the number of people fatally affected. It's a form of XY graph, which can be used to estimate at any point in time the number of people that can be injured if you are at any point of population, if the population has reduced or has increased. Now, the next is application of QRA. A case study will be discussed where this is one I personally informed. Now, we try to expand our facility in Ghana. The facility is actually has 140 million standard cubic feet capacity. Then we plan to expand it to 345 million standard cubic feet. Now, from process simulation, we identify two extreme scenarios: low pressure, high flow, then high pressure, low flow. Then we now look at hypothetical case, which is 60 bar in between. Now, the input data to QRA is atmospheric condition. We need to know how stable the wind and the wind direction, then the relative humidity of the area, wind stability, and solar radiation. Then you also need to identify from your process flow diagram and process piping and instrumentation diagram, you need to identify your isolatable section. This is a section that is being determined based on your PSV, BDV, and SDV to determine the number of infantry you can have in that area to determine your release rate. Then these are the ones we consider for that project: incoming pipeline, HP process gas, LP process gas, fuel gas section, vent system, diesel generator system, gas generator system, and export line. Then frequency and consequence model. After you gather your information, there are some manual calculations you are going to do. Then you now going to employ the use of software. For instance, we use safety. That's the software that was used for this project, but there is a DMV per set. There is also SIIIRSM that can be used for this modeling. Now, from your solid table section and hydrocarbon resource identification, you are going to carry out your frequency assessment, then consequence model, where you are going to take cognizance of fire and explosion, and you are going to calculate their effect in terms of value number. Now, the result is going to come out as a risk screening. For instance, if you look at local specific individual risk, it's usually mapped around the area as a risk control isoplate. Why, if you get your value for individual risk per annum, it's going to be in terms of number where you can compare it with risk tolerability criteria in ISO 17776, which is usually employed for this study. Now, this is a typical isolatable PFD that we use for this project. Like I said earlier, isolatable inventory is the fluid quantity contained in an isolatable session, and isolatable session is a process or utility plant session containing both piping and equipment defined by the following boundary: SDV, BDV, and PSV. Basically, the data for each of those piping, valve, equipment, the failure data is usually available in yellow book or OGP data, failure or leak frequency data. Those are the data you are going to use as a basis, as input to this study. Like I said, that's our case study. If you look at this page of my presentation, this risk zone, the first one is for workers within the facility, which look at low risk area, medium risk area, and the other side to my right here is for the public. Now, if you look at the case number one that I talked about, 345 at 23 Baji, we got a risk, we got individual risk per annum of 6.8 times 10 raised to the power minus 5. And also for the other case, which is a low flow high pressure, we got 9.1 10 raised to the power minus 5. If you compare this with the risk tolerability criteria I put down there, you see that they fall within the medium risk, which is not acceptable. Now, which is not acceptable. Now, this is a typical presentation of local specific individual risk. This is how it's going to present it to you. Now, if you look at the red ISO plate, which is risk control, that is high risk area. All the building around that area, they will be impacted if there is a jet fire and there will be explosion. Then the same thing for the second case, which is 23. You can see that the high risk area is within the WAPO facility. It does not go outside the facility. It's just the medium risk area that is outside the facility. And for the hypothetical, you can see some of the high risk area is outside the facility, which means that it presents the risk to the people living around that facility. Now, what is the next line of action to do? Now, the conclusion is factually inadequate safety gap between the newly upgraded plant and the houses present near the east fence is generally intolerable. There's no adequate safeguard. And because of this, there are mitigations we put in place. We have 3 mitigations. The first as in terms of recommendation from the study. The first mitigation is for us to relocate, to remodel the facility so that the high pressure side can move away from the east fence where the public is. But that will be difficult because this is a brownfield facility. We have an existing facility already. We just want to expand it. For you to do that, you can only do that if it is a greenfield facility where you can review the layout. Now, the next recommendation is to look at relocation of the houses around that yellow and red area. But that the government has no political will to do that. A team was constituted, headed by Deputy Minister, but unfortunately, they could not do much because they feel that the opposition will use that against them in the forthcoming election. Now, what we are left with as an option is reduction in potential leak point and operating pressure. Hence, the capacity of the plant was reduced to 235 and the inlet pressure of 55 is being proposed. Then we now install HIP to maintain that 55. Anytime the pressure to the facility is above 55, the HIP, that's high integrity pressure protection system, we activate and shut down the facility to minimize the impact. And also reducing the capacity. For instance, we have 2 existing runs. We are supposed to install another 2 existing runs. If we do that, the number of potential leak points that's multiplied by 2, which is more like 100% increment. Now, because of that, we are now forced to reduce the run to only one. We have two existing, we now add additional one runs. And with that, the potential leak just increased by 50%, and which has also favored the QRA result. And because of that, we are able to control the facility with the permission of the EPA, which is a regulatory agent, because they involved in this study. And currently the facility is running and okay. I think I will just present this as a file to note. It's good to note that QRA is one of the structured and scientific approach to genuinely demonstrate to relevant stakeholders, both workers, public, regulator, and investor, that inherent major risk in the proposed hazard plant has been identified, assessed, and mitigated to as low as reasonably practicable to minimize domino effect of major accidents. Also, it also demonstrates that safety of life and property have been adequately assessed and guaranteed, provided all identified safety critical equipment, processes, and procedures are maintained and operated within design and operating intent in line with best engineering practice in the industry. In a nutshell, QRA is one of the critical technical safety study required as part of the engineering package to take final investment decision in any typical project prior to approval to proceed to EPIC to demonstrate adequacy of safe distance between the plant, the residential areas near the facility fence, and in case there is a major accident scenario, such as jet fire, blast fire, pool fire, and vapor cloud explosion. And basically, this is what QRA is all about. Thank you for your attention. Thank you. This is the end of the presentation. Thank you so much for your time. These are the reference if you want to read further about this QRA. Thank you.
Okay, thank you, Engineer Raheem Alabi, for this the enriching presentation. In fact, our knowledge of quantitative risk assessment as a process safety engineering tool has been heightened by this presentation. Before the floor is open for question and answers, I'd like to also welcome the senior fellows in our midst. We have the immediate past president. We have also Professor Nebare. We have Engineer Dr. Irene. We have Engineer Said also. And then we have Professor Adefila. You are welcome. So the floor is now open for questions and answers. To make it orderly, we'd like to have indication by a show of raise of hand, please. Okay, the first person here is Engineer Stephen James. Please go ahead. Engineer Stephen, go ahead with your question, please. Engineer Stephen, can you unmute yourself, please? Unmute yourself, please.
Okay. I said I want to thank God. I want to thank Engineer Raheem for the presentation. Like Engineer Mahmoud said, it's quite very, very instructive and nice one for us. My question is around the issue of hazardous area classification. I see that it's very, very important that going by your presentation, this aspect, how do we enforce it in the neighborhood? Fine. In the major industry, it could be very easy, but look at the environment, our typical environment, siting of petrol station and some other things. Though you mentioned some things in your presentation, but to me, it's a key at this level. And like you mentioned, a lot of these, the property are already in place. So how do we bring it in, especially the enforcement agents? on the part of the government, at least going forward, how do we, implement this aspect so that we keep safety of our people? Thank you.
Okay, thank you. I think we may need to gather like few questions so that we can answer them together. Or what do you think, coordinator?
Okay, yes, from what I can see, it's only Engineer Stephen James that has indicated interest to ask. So I think you can go ahead and respond to him while
okay.
others coming.
Sorry,
Okay.
I could not get the raising of hand, please. Adetona. I'm sorry.
Oh, okay, just hold on. Okay, just hold on since you have a question. So, Engineer Alabi, so what we can do, no, just hold on. Let Adetona ask his question, then you can take both together. If additional one comes, then we wait until when we get all the questions. So, Adetona, you can go ahead and ask your question.
Okay. Thank you, Engineer Alabi, for the loaded presentation. Well, I just want to ask the risk tolerability criteria from the presentation. It affects the rating of either it's low, medium, and high. What are the guidelines we use, especially for a wide project that you did, to determine the risk tolerability criteria? Second one, the safety critical equipment that evolved from the study, how are they linked in terms of practice into the preventive maintenance of the plant? Thank you.
Okay. Okay. Any other question, or I can attend to this?
No, I think you can attend because they are the only two that have interest and have asked us. So you can go ahead and respond to them, please.
Okay, thank you. I will start with Engineer Stephen James. The issue of enforcement has been the major problem, as I said. And you know, we had the same problem in this project. Like I said, it will be easy for us to maintain the initial design capacity of 345. But because the government did not have political way to relocate people around the facility. Now, as a responsible operator of the plant, we felt that we can't continue like this. We need to find a way so that if somebody asks us, and eventually they get hold of the QRA report that have said that there are potential risks to people living around there, then that's what we do in our own case. But as regard the LPG flow station, I think it is still DPR that can help us. Like we said earlier, I think this issue was discussed in the first or second presentation that we had, that we need to get our DPR to swing into action so that they can help us to enforce some of these things. Because for instance, existing facility, if they still want to maintain it, the only option is to install blast wall, firewall around the facility. Now, will they have enough distance to install that? Because if the distance is not enough, the blast wall need to go as high as possible so that it can prevent that explosion overpressure risk. Basically, but the issue enforcement is still going to be within the government purview. It's government that can help us. We need political way to enforce some of those regulations. Thank you. I don't know whether I've answered your question.
Yeah, thank you. That's fair.
Okay. Engineer Tonosa, the issue of tolerability criteria, as I put in my presentation, is actually obtained from ISO 17776, which has to do with major accident hazard. That is where we adopt it from. It's a generic risk. And I think it's acceptable, being a renowned standard in the industry. Then the issue of safety critical equipment. Those safety critical equipment, after we identify them, we subject them to further both analysis, then equipment criticality analysis to determine the potential risk they contribute to. Now, based on that, in our computerized maintenance management system, we use Massimo. We tag them safety critical equipment, and we now upload the both the OEM recommendation for maintenance, such as preventive maintenance. We upload them, and we have procedure attached to those SE. And from there, that's what we follow to maintain them and make sure that the work as intended. Basically, that's what we did so far. I don't know whether I answered your question.
Thank you so much, sir.
Can I ask a question?
Yes.
Can I ask?
Yes,
Coordinator.
yes,
Okay.
go ahead. No, yes, go ahead. Introduce yourself and ask, please.
Yes, my name is Andy Yakubu.
Okay, welcome, sir.
You're welcome, sir.
Thank you. Thank you for this wonderful presentation. I don't know, sorry, I came late. I don't know whether this is also a condition precedent to FID.
Yeah.
If it is, I overheard you say that, there is no political will to relocate people. In a project, one of the conditions precedent is site acquisition, and site acquisition also has a requirement for what we call socioeconomic impact assessment in addition to the EIA, and also a relocation action plan. These are all conditions precedent to obtaining financing from global bodies like World Bank. So how comes this the very project you are telling us, was it an encroachment by the people, or the people were there and the project was located in their vicinity without due consideration to relocation action plan?
Okay, sir. Thank you, sir. As you said earlier, it's a condition precedent to FID. And basically, when that facility was built, that was 2006, 2007. There was nobody around that facility. It was an issue of encroachment.
It's encroachment.
Yeah, it was an issue of encroachment. And,
okay,
you know, unfortunately, government is not ready to tamper with any communities so that it will not be used against them. That's where the issue is. Thank you, sir.
Well, sorry, that is an action really that we need to flag up, because issue of encroachment has been a very serious issue. You just look at the pipeline from Escravos to Lagos. Look at the encroachment we have already and the impact it has over time. There was a right of way which people encroached on. So, and the bitter experience is what we are living with today. So I think it's something that the society needs to take up to see how the enforcement aspect of it can work. We also have Atlas Cove to Mosimi, where a whole village has been relocated called Arepo, and we know the negative impact it's having on critical national assets. So these are issues that we can flag off and take on board as action items. Thank you.
Thank you, sir.
Yeah, okay, thank you. Thank you, sir. We have I think the deputy president has question to ask. Go ahead, sir.
Yeah, thank you very much. I also, like my former boss, I joined lately, but I just met it at the case study. But as a follow-up to Dr. Engineer Andy Akubu's question, really what came to my mind is we ended up limiting our operating pressure because of this safety issue. Did we at any time consider any cost-benefit analysis for us to have taken up the relocation cost on board so that we can now have the free hand to operate at a higher pressure should the need arise?
Hello, sir.
Yeah.
Yeah, that was actually considered because a team of stakeholders was constituted to look at that. But being that it will take time to relocate people, and the facility is critical as national asset to the Ghana government because that's the only place they get gas from. Now, what can we do in the interim to ensure that we continue to flow gas so that they can power their national electricity generators? And that is why this step is taken at that point in time. But we are also considering situation whereby in future we are going to review this and we are going to come out with an holistic approach to this. If they are able to relocate the community around that area.
Yeah, really, that's why I'm a little bothered. Because I don't know. I didn't join early. I don't know which facility it is in Ghana. Are you referring to Tema?
Okay, yeah, it's our Tema facility, sir. Yes, sir.
Okay, you see,
it's our Tema facility.
If you are talking of Tema, definitely the chances of growth is very, very high there.
Yes.
So I would have just thought that the recommendation should have been just to take on board that relocation now, that the cost may be lower, because future encroachment will come up, and then at the end of the day, at the time when you need to expand or double the capacity of the station and operate at a higher pressure, at that time the cost of relocation may be prohibitive. So
you are very right, sir. The major challenge we have is, like I said in my presentation, a team of stakeholders were put together. Deputy manager of energy, he is the head of that team, but he could not push much because they were looking at it from political perspective that the opposition can use it against them. They have to move people and force them to leave their houses and all that. That is where the challenge is, sir.
Okay. That's okay from me. Thanks.
Thank you, sir.
Okay, thank you very much for all your contributions. We don't have any further hand raised. Therefore, I would like to call on Dr. Obakar Usman to give us a wrap up of what has been discussed.
Okay. Hello.
Yes, go ahead.
Can you hear me?
We can hear, but you are breaking up.
Can you hear me?
Yes, you are breaking up, but you are breaking up.
Okay. What about? Okay. What about now?
Is now it better now, better.
Better, right?
Yes, better.
Okay. So, Engineer Alabi. Okay, Engineer Alabi, thank you very much for the very resourceful presentation. Actually, I enjoyed the Q&A segment, and I'm sure many of the other participants do. It was what I call R-square, rich and real, where the QRA figures were actually mapped onto reality of operations and socioeconomic realities. So I think that's very interesting. So to start with, I think Engineer Alabi started by defining the term risk, which is essentially probability of something bad happening. And he then went ahead to mention that risk is defined by two important parameters, accident frequency or incident frequency, and the expected negative consequences. We put this together to have an estimate of the risk. And then regarding the qualitative risk assessment, for QRA purposes, we have two main types of evaluation inputs. So we have the scaled magnitude and pure numeric inputs. Examples of the scaled magnitude input are qualifiers such as low, medium, high, yes or no. Sometimes you come across short-term, long-term, adverse or beneficial, and so on. All these are scaled magnitude inputs. So QRA deals with that. And then when both frequency and consequence are subjectively assigned scale magnitude in order to estimate the risk. So you have medium, low or high assigned to both frequency and consequence, what you have is qualitative risk assessment result. So the final results are not presented in pure numeric measures. But for the quantitative risk assessment, you have pure numeric numbers assigned to both frequency and expected consequences. And Engineer Alabi also went ahead to distinguish between quantitative and qualitative in clearer terms. So quantitative risk assessment is highly dependent on accuracy of the data we use, while qualitative is largely dependent on judgments, experiences, and course of practice. He also mentioned that quantitative risk assessment is relatively more objective, while qualitative is relatively more subjective, and qualitative is less time consuming, while quantitative is usually more time consuming and more expensive to implement. And normally, qualitative risk methods are the first choice for many projects. Quantitative techniques are only employed when there is high risk potential that is not reasonably understood, or if there is a prescriptive regulatory requirement. Engineer Alabi also highlighted he gave a simplified version of the QRA process, which started with data collection, hazard identification, then frequency and consequence estimation, and then you put these two together to evaluate the risk, and then you look at the risk tolerability criteria. If the risk is adjusted to be tolerable, the risk assessment recommends maintenance of the status quo, and of course taking cognizance of the regulatory requirements, standards, and so on. However, if the risk is considered to be unacceptable, the existing mitigation measures may have to be enhanced, usually by reviewing the set of independent protection layers built into the plant. And the first and the most effective layer is integration of the inherently safer philosophy into the design, operations, and maintenance activities, among others. So depending on the outcome of this review, either the frequency, the consequence, or both will have to be driven down, to reduce the risk. This then changes the overall risk profile. This iterative process continues until the residual risk is below an acceptable limit. Engineer also used a case study to demonstrate applicability of the QRA concept. Input data include atmospheric data, so wind direction, wind speed, temperature, pressure, flow, input, and so on. So consequence modeling results of the study include overpressure figures on receptors within certain radius, and these were combined with the incident frequency figures to evaluate the risk. So based on the QRA results, hello?
No, we can hear. We are still with you.
I hear you,
Can
sir.
you hear me?
No, go ahead. We are still with you. We can hear.
Hello?
We are hearing
Go
you,
ahead.
sir.
Go ahead. Go ahead, please.
Make it snappy, not a repeat of the lecture, please.
Hello?
Was supposed to.
Make it snappy. Not a wrap up is not a repeat of the lecture. Oh.
Did you hear that, Dr. Osman? Hello, can you hear us, please? Yes, can you hear us? Can you hear us?
It has dropped up.
So
Okay.
Conclude. So just quickly, let me highlight on the.
Maybe just maybe 1 or 2 minutes, please, Dr. Osman, please. 1 or 2 minutes, please.
Okay, so finally, okay, so those the bullet points towards the end. Engineer also highlight. Yes, I can hear you. Let me. Okay, so he also highlighted. Yes, yes, I can. Yes, I can. Yes, clearly. I can hear you. I can hear you clearly.
Okay, I think, Dr. Usman, I think you're almost concluding, but it appears that we have issues hearing you. So, but I think that...
I thought 1 minute. Can you hear me? Can I make progress?
No, I think we have issues hearing you, and it appears you have almost concluded, yeah? So can we, because, yeah, I think we can just end it here, Dr. Usman. We have issues really hearing the last bit of it.
Hello.
What about... Hello, Dr. Usman?
There's connection problem.
Dr. Usman? Okay, I think we will end it here. We'll end the wrap up here. I think you've done well. Thank you very much. I think we have network issues from your end. So thank you very much, Dr. Usman. I can see that Dr. Hello, Dr. Erin, please. I see that you are raising your hand. Can you just go ahead and comment, please? Dr. John Erin, please.
Yeah. Okay, thank you, Mr. Chairman.
Yeah. Yeah.
I suggest that you better mute.
Your microphone
mute.
is muted.
Yeah.
Microphone. Dr. Ine, your microphone is muted.
Unmute yourself, Dr. Erin, please. Unmute yourself.
I think it's frozen out.
PPRESENTER, please.
It's frozen out.
I think we have weather challenge. We have heavy rain over here, so we just have to cope with the... Yeah.
Like heavy rain in Abuja.
No, I think you're right. Yeah, even in Zaria as well. I think Dr. Usman too has that area.
We are not all in Abuja. Yeah. Dr. Ine, your microphone is muted.
Dr. Erin, if you can hear us, just unmute yourself, please.
You cannot.
Okay, I think that is the. I think that's the.
Do you hear me now? Hello.
Yeah, oh yes, go ahead. We can hear you. Go ahead, please.
Finally, you have joined us.
Yeah. Okay, sorry. Yeah, Engineer Alabi, I thank you for a very interesting presentation on QRA, which is a robust process safety tool. Just while we're on this, just want to ask one or two more generic questions. From what you just said, Ghana is quite heavily dependent on natural gas for power generation now. But in years past, we knew that Ghana was dependent on the Volta hydro power system for most of their power supply. What kind of balance does Ghana have now, just for our own information, and for us to put things in full perspective? What kind of balance does Ghana have between hydro and thermal power generation?
They have more of thermal, because because of seasonal change in the water flow, they don't rely much on hydro that much. Is basically their primary source of generation is thermal now. They just put those hydro as a backup in case there is no gas availability and all that. I don't know if you can hear me.
Yes, I can hear, yeah.
Okay, that does it. More like 70-30 now.
Oh, okay, that's quite massive. Now, another question will be, the gas plant you were trying to expand,
yes.
what is the scope of operation of that plant? Is it just does it also have a splitting facility, fractionation to separate some heavier fractions, or just dehydration and sweetening?
No. We don't even have, we are taking processed gas from from NGC. It's a processed gas already. You just have scrubber to scrub in case of condensation because it passed through offshore plant, which is at around 115 degrees C. Then after that, we take it to filters. We take it to heater, where we are going to raise the temperature from 15 degrees C to 29 degrees C that is required by customer. Then we subject it to filtration, which is more like to remove any drop particles or droplets from the gas before going to customer. Those are the three processes we carry out on the gas, because usually process from.
So this is the gas from Nigeria, not the gas from offshore Ghana. Yes,
from Nigeria. Then they have another source. The expansion we did is because there is another source from offshore Ghana now. Because that's the expansion we did.
Okay, all right. Thank you very much.
You're welcome.
Okay, so thank you. Thank you for all your contributions. Who wants to talk?
No, I just wanted to add we are talking for information really, so I just wanted to add a point.
Okay, go ahead.
One is that it's not only the lower water level that is making the thermal to grow, but also the hydro too are very old plants, so they have technical issues too. So they would rather go on the base load for thermal and then back up whenever necessary with whatever unit is available on the hydro. And then secondly, also, the thermal station is predominantly for gas coming from the east, that is from the Lagos end, from Nigeria. But the additional gas that Alabi is talking about will not see thermal, will only see Takoradi. So this particular thermal station is only for gas coming from Nigeria.
Okay, thank you.
Just
thank
a clarification, that's all.
All right, yeah. Thank you very much for the added information. It's they've been explicit and it has been a worthwhile conversation. The time is far well spent, and we are supposed to have closed by 5:30. I'd like to call on the president to give his closing remarks.
Just a small remark.
Thank you, David.
Before the president comes.
Andy?
Mr. President.
Yes, Andy.
Mr. President, it's just attitude, and I must say that many of us are very happy. Those of us who fall into the grandfathers of the project, it's nice to hear many years after that we're at this stage. So I'm happy.
Thank you, sir.
Thank you, Alabi. Raheem, you can see that we've had a most brilliant outing for you. I thoroughly enjoyed the presentation, and I thoroughly enjoyed the feedback, question and answer. I also enjoyed the enriching additions from the grandfathers of the project, former GMD Andy Yakubu and my DMP, Sayyid Mohammed. It is obvious that the tools that the society possess to assist government and industry to better manage affairs in our country is really unparalleled. Each time I listen to this presentation from the highly qualified resource persons, I get a lot more encouraged that the future is bright for our country, the future is bright for our society. Your presentation is super great, and I want to congratulate you.
Thank you, sir.
I also want to thank Engineer Dadet for his able management of the presentation. I want to thank, as always, Engineer Mahmoud for the leadership that he has continued to provide for the HSE sectorial group, which has given rise to these presentations. I want to thank all the participants, because without participants, it will not be as successful. I am also beginning to see new names. I encourage more new names on the platform as we go ahead. And I also encourage the old names to be steadfast in showing up, because clearly the experience they had, both from the questions they asked and the comments they made, are invaluable. They are part of the total package of this presentation series. So on that note, while looking forward to another stellar presentation from this group, I want to thank all of you and hand over to Mahmoud if he's around. Mahmoud, if you are around.
Okay, no, Mahmoud is not here. That's what yes, I'm standing in.
Hand over to you to please close the session.
All right, thank you, President. We are really happy that you've given these enriching remarks. Again, thank you very much for being part of the event this evening. In closing, I would like to call on Engineer Awal Haruna to give us a closing prayer. Engineer Awal Haruna, are you there?
Yes, I'm here, sir.
Okay, please give us a closing prayer.
Hello, sir, can you hear me? I'm having some challenge with my network here.
We can hear you.
We can hear you.
All right.
Okay, go ahead. Go ahead. Go ahead.
Go ahead, Kyary, don't worry.
Hello, can you hear me, sir?
Yes, we said you should give us closing prayer.
I'm still struggling to connect. Maybe someone should please step.
Okay, please, Engineer Tukulawal, go ahead, please. Just give us a closing prayer. Engineer Tukulawal.
Oh, God of mercy, may you continue to guide our leaders right. May you give us solution to all the problems we know and those who do not know. Thank you very much. Amen.
Amen.
Amen. All right, thank you. Thank you very much. Thanks a lot. Thank you. Bye.
Bye. Thank you.
Bye-bye. Enjoy your weekend.
Bye. Thank you. Thank you so
Bye.
Bye. Thank you.
Bye. Thank you.
Everybody.
I'm not going to about this everybody for grounds. Now they carry my tell go front and forward. People will go church tomorrow. When I go wear face mask. When I